Can you hear me okay? Yeah, sure, awesome. So good morning and welcome everybody to the Road to Web Performance in 3 critical steps. Wow, that's a tongue twister right there. So my name, like it was presented, my name is Hernan, and I work for Udacity as a front-end engineer. I work for the European branch based out of Berlin. For those of you who do not know about Udacity, our main objective is to democratize education through online courses. Most of them are related to software development. And one of our main goals is to provide support to individuals across the whole world that want to empower themselves to learn new skills for software development in this case. So this is why in the engineering department, it's really important for us to be as performant as we can. Because, again, we don't know exactly where our users are coming from, and we need to deliver the best performance that we can for them. And also, performance is, for me, a really passionate topic that is really close to my heart, and this is why I chose this topic for this talk. But before we move forward, I wanted to set your expectations a bit, because sadly, there are multiple topics that I want to talk to you about, but we don't have enough time to actually dive too deep into them. I could potentially talk about 1 hour on each of these topics, so it's pretty extensive. But what we are going to be talking about is trying to make you understand the process that we go through at Udacity to develop our techniques in order to have a performance mindset when we are always shipping new code to the clients. And also, I would like to encourage you to follow up on your own, because this is a real part of your learning process. You have to go back to your place, do your homework after you attend this kind of conference, because otherwise it's just wasted knowledge. You just wasted an hour and a half here. So yeah, I should definitely want to encourage you to do that. I've said performance at least 10 times so far, and I don't have many synonyms for that, so get used to it. But one of the things I want to define first is, what is performance? So I want to ask you guys, what do you think performance is for you? Like, really quick, mention stuff. Come on, people, wake up. I got something back there. I couldn't hear it, but it was okay, cool. Speed, okay, awesome. So I'm going to show you 2 examples of how the Udacity's German website loads. Both of these examples are based on the same network conditions, and I chose the 3G network because pretty much a very average connection for mobile devices. So let's take a quick look at how the application loads here. Now it's loading user data, so it sets up the user status, and then everything's loaded. Now let's take a look at a second example of the same website during the same network conditions loading. All right, cool. So which one do you think was the one that delivered the content faster? The first one, right? So actually, both of them deliver the content at the same time. They're actually the same application. But the second one actually delays the rendering until all the content has been downloaded to the client. And why I said that we needed to define performance is because for us at Udacity, performance is rather an experience, more than just implementing steps for optimizing our code. And because of this, there are multiple things that are required for a good experience. It's kind of an abstract concept that is kind of difficult to grasp if you only have one way to measure it. Because of this, what we tend to do is to have as many data points as we can and gather multiple metrics. And even that, we are able to just grasp the concept of what a good experience is in terms of our users. So that's the first step that we take to performance at Udacity. We measure our stuff. We need to know what's going on in our applications at any given moment in time. And we need to know what our users are experiencing. So I want to go through some of the tools that we use day to day. Again, it's more like an overview of all the things that we do so that then you get back to your place and do your proper research on how to implement the stuff when it makes sense for you. So the first one is Renown, Chrome DevTools. It's a really powerful set of tools. One of the things that we can see is the network tab. The network tab is really powerful in the sense that it's really easy to identify what is going on, what is being rendered at each point in time, because it has a film strip view that shows us exactly what the application looks like during the loading of it. we also are able to have a waterfall view that tells us all of the requests that are being made and the order of how they're being made, which is really awesome to be able to identify bottlenecks, both in connections, in blocking rendering, or actually assets that are being blocked, the loading of follow-up assets. Next tab, we have, well, like rather the performance tab, which is really awesome because it shows you what the main thread is working on. As you know, most of the time JavaScript runs on only one thread unless you're using web workers. But here is really easy to see what scripts or what the browser is actually doing at any given point in time in your application. So we can identify script frames and the lower frame counts and the reason as to why that is happening. This is very useful, especially for applications that have a reliance on animations. So we can say, hey, I skipped a frame here. What's going on? Is this a script? Did I trigger a rendering or a painting event on the browser? And I missed my 16 milliseconds time frame, which, by the way, if you do not know, if you want to keep your applications at 60 FPS constantly, you have at around 16 milliseconds to do everything that you need to render an actual frame. And finally, I wanted to show you the other stuff, because this is one of the easiest ways to get feedback on what is going on with your application and what could be improved. So it's pretty much instant feedback on it. And although it's not one of the deepest dives, it's really cool because it shows you actionable items which you can immediately implement and work on it so that you are going to see a performance gain there. Next up is one of my favorite pages of there, Page Speed Insights. For those of you who do not know it, basically you put the URL of your website, and it's going to hit you with several sets of tests, performance related. The good thing about this website is that it's going to categorize these measurements, both for mobile and desktop, and it's actually going to run different tests depending on which platform it's actually trying to test. And in this case, for instance, what it does on top of what the audit stuff and the Chrome DevTools shows you is that it shows you feedback on like very basic UX advice. For instance, in mobile, if your buttons are smaller than 40 pixels, they're going to be really hard to actually be a touch target. So it's going to show you that kind of things. And it also shows you advanced techniques too, like critical inlining and deferring non-critical assets, which we're going to be talking about in a few minutes. Next up, we use also web page tests. I really love this website because it's very detailed. It shows you pretty much a collection of all measurements that we have talked about so far, but it shows you in a very visual way. So you have an AD rating for several metrics, such as effective use of CDN, the caching of your assets, compression during the wire, and all those kind of things, which are stuff that we normally don't pay attention to, but it's really useful to see exactly what's going on in your application. It also has a film strip view like Chrome DevTools has. The only difference is that you can actually download the video that is going to show you how the application is being loaded in these tests. One of the things I love most about this website is that you can actually set up multiple passes, which is really important because we don't want to have only one set of data. We want to gather as much data as we actually can. So you can set up multiple passes to hit the same test on your application. And you can also set different locations, such as the server location, like in this case is Frankfurt, but you can pretty much set any other location of several servers that they have available. The same for the browsers. And finally, the next tool that I wanted to show you guys is Lighthouse. So Lighthouse is a Chrome plugin, and it's also available as a CLI. The idea behind Lighthouse is that it's going to collect modern performance metrics. It's going to show you developer best practices and advices based on that. Although it's kind of focused on progressive web apps, it shows you a very detailed report on performance and accessibility. And again, it also gives you a list of actionable items in which you can immediately work on and see and direct impact in your performance. As of right now, I think it's available in Chrome Canary by default as the audit stuff. So if you use Chrome Canary, you're going to be able to see a very similar report on this. And soon enough, it's going to be in Chrome Stable as well. So this is really great. And all these metrics are really necessary for us to understand and have insights on our application. But those are kind of only lab tests. I mean, they're lab results. And they can be useful for forecasting regression and having these insights. but they do not show you the full picture of what your users are actually experiencing. So out there in the world, we have a really wild set of situations and conditions that are really hard to simulate for us to be able to test. You have multiple devices, you have multiple OSs, multiple browsers, multiple connections types. Again, you have people who have malware downloading at the same time that they're watching a stream movie or whatever. So it's really difficult to try to understand that and be able to simulate those conditions. Because of this, what we implemented are some sort of metrics that will allow us to gather these metrics directly from the end users. So how do we actually do that? Thankfully enough, as of very recently, the Chrome and the actual spec has been laid out for the performance API. So the performance API is going to allow us to track different performance metrics through a performance observer. And in this case, it allows us to subscribe to this type of metrics after the events happens. And of course, we are going to be able to respond to these events like whatever we need to. So we can send those events to whatever Google Analytics or analytics service we actually use. So in this case, first pane and first contentful pane mean the time that it takes for your application to actually show some content and show meaningful content to the user. So you see here that, where's the mouse? Okay, cool. So it's really easy to implement. So you only subscribe to the entry type of paint. You're going to receive either the first paint or first contentful paint events. You're going to receive the start time and the amount of duration that event took. And you can send that to analytics so you can track all of this for your actual users in the real world. Next up, one of the things that we also track are long tasks. So long tasks are defined by a script execution that takes way too long for us and will often cause like really bad user experience. Have you ever been on a mobile device where there is an event handler attached to the scroll event, and when you actually try to scroll, it takes a few milliseconds to actually interact with it? There is a noticeable lag. So that kind of negative user experience is caused by these long tasks. And the API is pretty much the same. It also uses the performance observer, and we also have to subscribe to the entry type long task. The only thing that it adds as well is it has an attribution property here, which tells you the frame context of what the script was that was causing this long task. This is really helpful for you guys if you are using third-party scripts. So it's going to say you, hey, there's an iframe, and this is the context that is causing that long task to cause issues for your users. And finally, the other metric that we track as well is time to interactive. The time to interactive is defined as the time that it takes to your application to be able to respond to user events. That means, again, when you touch a button, the time that it takes your application to actually be able to respond to that event. The version here, so this is really a really difficult metric to actually define in a way that is going to work for everybody. But Google did a really good job by implementing this polyfill, which is pretty much a promise, and you get the amount of time that your application took to actually be interactive and be able to respond to those events. So now that we have all these metrics and all this data, it's really important for us because then we can have our development process driven by this data. And we can then optimize, which is the next step, because we don't really want to be wasting time in micro-optimizations when they don't make sense. We want to be able to track and well, I don't want to say hunt, but we really want to be able to spend our really important time into assess the actual issues that the user is having. So I'm going to be really going overview of some of the tips and tricks that we actually implement, but you have to take them with a grain of salt because it definitely depends on your actual implementation and what makes sense to you. But all of them have kind of the same objective, which is to deliver content fast and to do it in a really smart way. We're not going to be talking about minification because that's pretty much a concept that everybody's already familiar with, but we are going to be talking about deferring non-critical assets. That means that we have a script, styles, fonts, and onto some context images are all assets that block the rendering of our application. And what we want to do is to be able to allow the browser to be able to continue rendering without actually waiting for these assets, especially if they are not meaningful for our users. This is pretty much what we know as optimizing for the critical path. The way that the browsers works is that when they encounter one of these reference to this kind of assets, they're going to pause the rendering until that asset is actually downloaded. So we want to avoid that. And we're going to be looking at some of the different approaches that we can take for all of these assets to be able to defer them and only load exactly what we need to show content to the user as fast as possible. When I talk about JavaScript optimization, we're not going to be looking at really specific stuff like lazy loading, using Google Closure Compiler, or pre-rendering your stuff, because that's really specific to the content or context of your application. You might be using React, Angular, or no framework at all. So it's really context dependent, and it really depends on what actually makes sense for your application or what your application is actually able to do. So we're going to be talking about deferring this type of scripts. In order to be able to do that, we have several easy-to-implement tools, like the script async attribute, which what it's going to allow you is tell the browser to download that script. Also, by the way, it's pretty much usable in every evergreen browser. What it's going to allow you is to download that script, and the browser is not going to pause the rendering until that script is actually loaded. Then it's going to pause its parsing of the document. It's going to execute and parse and execute the script, and then it's going to continue parsing your DOM. So because of this, the order of the execution of the scripts is not really guaranteed, because you have multiple scripts defined, and they have different sizes, and there's different network connections. They're going to take different times to load, so they're going to be executed in the time to the fastest to the slowest. But we do have the script defer attribute, which works pretty much the same way. So it's not going to block the rendering for your browser, but it's going to preserve the execution order. So if you define 4 or 5 scripts, regardless of how they are actually finished loaded, they're going to be executed in the order in which they were put in the document. Next up, we have CSS optimization. And when I talk about this, it's again identifying non-critical CSS that we need to defer. And in order to be able to do that, we actually have to identify the critical CSS, which is, by definition, every CSS that is needed to be able to render the content that is above the fold. That is the content that the user first sees when the browser is loading your application. This has like a huge performance impact, because CSS can then be immediately rendered, because normally what we do is identify the critical CSS, and we just inline it on the document itself. And it also unblocks the rendering, because there are no longer links that are going to tell the browser, hey, wait for me to be able to continue your rendering. But because identifying critical CSS can be really hard, there are package manager, NPM packages that help you with this, like Penthouse or Critical, I think it's called. But still, it's really context dependent, and depending on your application, your setup, and the size of your application, it might be really difficult to implement this. But there are still other techniques that we can use to unblock the rendering of your application. So it's important to understand that CSS is a render blocking asset. That means that the browser is not going to render anything until the CSS home is constructed. So one trick that we can do is use the media attribute, because the media types and media queries that we define here will tell the browser, hey, you can download this CSS if you want, but you're not going to have to block the rendering, because they're probably not going to be applied unless that media type or media query actually is true for the given context. So that way, you're only going to be blocking the rendering for those assets that actually matter, and not for mobile when you're actually on desktop. And this is kind of one of the mildest techniques I'm going to describe so far. But it's pretty common to use frameworks like Bootstrap or Foundation or Angular Material, and we can kind of tend to forget about everything that we are actually importing and not care about it. But there are tools that let you identify all of the CSS that is actually not meaningful for your content, and we can strip that out of the bundle. There are tools such as NCSS. We can help you with that. Font optimization is the next step, because again, fonts are not really a critical asset at all. And because fonts are hard, fonts are slow, I have a few pointers for you guys to how to deal with them. Use fewer fonts. I know that if there are any designers in the room, they're not going to be amused by this, but when I say use fewer fonts, it's not just about avoiding as many custom fonts as you want, although like the rule of thumb is not to use more than 2, because then you're going to have a lot of issues. But also, if you know that your content is not going to use every character within the font, you can strip every character that is not being used and only load the ones that you're actually going to be used for the content and load everything else asynchronously, which takes us to actually how to load fonts asynchronously. Because again, font blocks rendering, and you can actually see, so let me zoom here just for a second. You can see here that here the actual content in the text is already on the client. The browser is blocking the rendering because that content is using a custom font, and it's not going to actually render that content until the font is actually loaded. So one of the things, this is called flash of invisible text. And one of the things that we can do is, via the font face on load polyfill, we can use a web font, which is a fallback, which is a default, which is what is shown. Let me zoom here again. So here what we are using actually is just a web fallback font. And we're going to apply the styles that actually set our custom font only once the actual font is loaded, so that we can show the content as fast as possible, and we do not block the rendering for that specific user. And this should be kind of obvious enough, but we should cache fonts aggressively. They don't change that often. Actually, they don't change pretty much at all. And you should make necessary precautions so that these fonts are only loaded once. Cool. So image optimization is kind of one of the things that is overlooked. We're not going to be talking about build processes like making your images smaller without losing actual quality. But one of the things that we do is we take really small images, like 5 by 5 pixels images, we scale them up, and we apply a blur effect. And then what we do with the script later on is to load the actual full resolution image, we replace that, and make the blur effect out. So what that means is that the user is going to see content already by default, in everything that is by default, and is not going to have to worry for all the image to load and just see white space there. And finally, because kind of following the same mindset, most of the applications just include every image to the whole document, whether the document is actually going to be able to show them because the user is above that content. So using the same technique, we just load progressively those full resolution images when it actually makes sense for the user, because then we're not using unnecessary resources. The next step is network optimization. I'm going to kind of script through because I'm running out of time, but gzipping is really important. It's really easy to implement, and it's one of the things that actually have a huge impact in the amount of data that's downloaded to your users. And even if you don't have a server in front of it, you can actually gzip your stuff during the build process. If you can, enable HTTP2 in your servers. It's a binary protocol. That means that there is a lot of time less consumed by the parser, and it's more compact over the wire. It has multiplexing. That means that we are able to download all of the requests from the same origin in parallel. And it only opens one TCP connection for every origin that we're referencing to, whereas HTTP1 is going to open pretty much one TCP connection for every origin that we are making reference to. Prefetch and preconnect pretty much help you reduce the latency, which is really important when your users are from all around the world, because international servers tend to have like between 100 to 300 milliseconds of latency, which is a huge amount of time in terms of performance. So take a look at this, because they're really cool. They pretty much allows the browser to set up all the connections necessary, like TCP handshake, TLS negotiation, and DNS resolution before you actually make the request to the server to fetch those assets. And the preload the preload value for the relationship attribute in the link helps us to when we have scripts that we know they're going to be loaded by some condition or at some point in the future of time, we can tell the browser to, hey, download this asset, but you're not going to be using it until I tell you to. So what we do is just reference that asset with the preload value, and once we actually need that asset, we just append it to the document, and then it's going to be parsed and executed by the browser. So most of these optimizations are kind of to improve the first load for users. But we talked about that performance is an experience, and a good experience is based on consistency. So because of this, the next step is to actually be consistent across every network that there is available out there, because we can't really trust networks. And we can optimize as much as we want. We can do everything possible, spend weeks and months optimizing for the first load. But if the network connection fails, the experience for the user is just going to be really slow and dreadful, regardless of all your hard work and effort. And there are especially two scenarios that we make, which have to try to make resilient our applications for, which is Li-Fi and offline. In this case, Li-Fi, for those of you who are not familiar with the concept, is when your phone tells you that you have a 3G connection and an HSPA connection, but you actually can't load anything. That means that your phone is lying to you. You don't have an actual connection. Therefore, Li-Fi. Yeah, I didn't invent it, so sue me. So there are several ways to do this. One of them is to use service workers, because it's pretty much for free. For those of you who are not really familiar yet with service workers, they are pretty much scripts that run in the background. And by kind of definition, they are programmable network proxy that tells how the network should behave for the requests that are being made by your application. I say for free because there are a ton of tools that help you with a lot of boilerplate. In this case, Google worked with Workbox and a lot of other libraries. This is pretty much like the successor to Service Worker Precache and Service Worker Toolbox. And it's focused kind of in modularity, so you can pick and choose whatever you want to actually implement. And it helps pretty much pre-cache your assets. That means that when the worker is installed, it's going to fetch all the assets to the network, save them to the cache, and then when the user goes back to your actual application, it's going to fetch all the assets that hasn't changed from the cache. Going to skip that. So in summary, we want to be able to deliver the best experience that we can. And in order to be able to do that, we have to be consistent as well. So there are really clear 3 steps to be able to actually achieve it. The first one is to measure. We need to define and instrument your metrics, and you have to be able to measure often and as wide as possible to gather as much data as you want. Again, the idea behind that is that once you have your metrics, you're going to be able to optimize based on them, and you're going to be able to be wasting time in micro-optimizations. And finally, you have to be consistent, because there might be network issues that you're not going to be prepared for, and even if you have the best first loading experience, if the network is not consistent, it's just going to suck. And I just wanted to show you really quick. Let me here. Right, so I'm going to show you that there's no server listening to that port. And as you can see, this is something that I'm currently working on. This is the German website for Udacity. And it's pretty much already cached on the service worker. And everything still works. I pre-populated the cache for some pages. So you can see that everything's still loading, even if I just go to pretty much every page here. So yeah, that's how we are trying to prepare ourselves to offline. Going back to here, I wanted to say thank you guys for bearing with me. I know I speak too fast because I didn't have enough time, but you should definitely do your homework. I'm going to be uploading the slides so that you have them as a baseline for you to be able to remember exactly what you should be looking into. So give me a follow on Twitter. I'm going to post them afterward the talk. Right, thank you.